My name is Heather Ruhl. I work with H.B. Fuller. Today we're just going to talk about what I think is one of the biggest challenges that we face in resilient flooring, which is, so you've got moisture, now what? For any of you guys that were at my last FCICA talk, we talked a lot about test methods and how to determine if you do or don't have moisture. So this is kind of the continuation of, okay, you did all the testing, you did everything right, you know there's an issue, what are you going to do now? I always like to start these out though with why do you care about moisture? And this is, I think a fantastic statistic. Every year it's estimated you spend $2.4 billion in the US, in North America, addressing moisture-related flooring failures every single year. Again, I like to give kind of a reference. How much is 2.4 billion? Well, I'll tell you what. A 2021 Ferrari Spider is about $507,000. For $2.4 billion, you could buy 4,734 sports cars. And I don't know about you guys, but I would rather have 4,734 Ferraris than moisture problems, right? So really in the end, $2.4 billion is a lot of money to spend fixing moisture-related issues, okay? So we're going to talk a little bit about moisture methods today. We're going to talk about the solutions. We're also going to do a really quick case study and then a short conclusion today. Now, I like to show flowcharts because I think they're one of the easiest ways to walk through what you should or shouldn't do, right? Because it gives a nice, easy overview of step by step, right? What are you going to do? So the first step in any job, right, is to know your flooring system. And that means know everything from the bottom up. What are you going over? Are you using a certain type of substrate prep, right? What kind of primers are you using? What kind of patch or levelers are you using? Not only that, but what are your adhesives? What can they or can't they do? And also, what type of flooring are you going to be installing? That's always the first step, knowing the entire system start to finish. And that helps you understand what steps you can take next if you do end up with moisture issues, okay? So, as we talked about last time, your next step is going to be to test your concrete for moisture. The main test method that we see people using is the ASTM 2170. The reason I really, really like this test method is it's quantitative. It's not a qualitative test. We've all seen or heard probably of the poor man's moisture test, which is just taping plastic over the concrete and it just tells you if there's moisture or not. This is an actual test method that gives you a specific number. And I like it because it's an electronic reading, right? The number is there, the number is shown. It's not it could be, 80% RH, it could be 82. There is a quantitative number that is given at the end of this test method, okay? Now, we also probably have heard of the slightly older test method, which is the ASTM F1869. This, again, is a quantitative test method, and it's also known as the calcium chloride test. But the challenge with this one is it takes longer than the RH meter, and it's a little bit more subject to ambient conditions and the condition of the concrete at the time. And what's really important between these two test methods is to understand that there's no direct correlation between the two, right? I wish I could tell you that, it's like Celsius to Fahrenheit, where there's just an equation that you put it into and you can convert the calcium chloride test into the relative humidity test. And unfortunately, right now, there's really no direct correlation. So that means that if you do the calcium chloride test, you need to make sure you have all the information on your products in moisture vapor emission rates. If you do your testing in RH, again, you need to make sure that you know everything in your system with your, with relation to RH. So just keep in mind, these aren't something that you can just quick equilate, or maybe you do calcium chloride to start and you move to RH. You need to kind of pick one and know the stats of all of your product based on the, whatever your test method is, okay? So with that, of course, every single person's dream is that there's going to be low moisture present based on that testing, right? So what do you do then? You can proceed with your installation. But it's important to note that whatever your moisture rating is, let's say it's 80%, 75%, every single part of your system has to be able to withstand that high moisture, or that moisture level, right? So again, if it's 80% RH, your primer, your self-leveler, your patch, your adhesive, and your flooring has to be able to withstand that type, the relative humidity or the moisture vapor emissions that you measured, okay? So just because you've got a primer that can do it doesn't mean that the whole system is able to handle that type of moisture. So it's a really good thing to keep in mind that it's not just one part of the system needs to be able to withstand the moisture, it's the entire system. So let's talk about what happens if there's high moisture present. Well, it's really important when there is higher moisture levels present to figure out where is it coming from. And there's kind of two places that you'll typically see moisture coming from. It's either going to be moisture of convenience or moisture from the environment, okay? So what is environmental moisture? Well, it could be groundwater, it could be precipitation, it could be poor grading, it could be a lot of different things, right? And really the only thing you can do with this is to fix the environmental issue. So if there's a pipe that has a leak or that burst, you need to fix that before continuing with the installation. We've had ones in the past where, again, grading has sloped towards the building and it causes water to puddle up along the foundation, which then causes moisture issues directly on the other side of that wall. So fixing the grading, fixing the burst pipe or the sprinkler system that shoots water directly at the building and again gets moisture into that, foundation, you have to fix those issues before you can proceed with the installation. Because in the end, if you've got a burst pipe, if you've got something that's forcing moisture into your system, if you don't fix it, you're going to be part of those $2.4 billion in failures. So really important to just, if it is an environmental thing, fix the environmental issue, okay? I always like to bring this up because I think it's something that can very easily be misunderstood. Most of the things that we talk about when it comes to resilient flooring and preventing moisture failures has to do with moisture. There's a difference though between moisture and liquid water, okay? Liquid water, also known as hydrostatic pressure, is liquid water exerting a force on that concrete. Typically, you're going to see that below or at grade. Again, it's typically due to a high water table or, again, sloping or something related to that is forcing a lot of water into that slab. And in the end, you need a structural engineer or, some other professional to come in to determine what do you need to do to remove the liquid water. And I wish I could tell you that liquid water is something that, we could come in and give you a magical solution for. Unfortunately, kind of the only solution for actual liquid is to remediate the source of that liquid, right? And then you can go back and readjust and determine, are the moisture vapor emissions now acceptable now that that's been remediated, or is there still an issue, okay? So fix the environmental issue, and I understand that's not always as easy as one thinks, or, do you need to look into moisture mitigation? So I just kind of want to really quick bring up the fact that, again, if you've got a burst pipe, if you've got some type of environmental thing that should be fixed, moisture mitigation shouldn't be the solution. But there is a reality that most slabs, I should say, should have this yellow plastic underneath it, which is a moisture vapor retarder. The reality, though, is that over time, that moisture vapor retarder that should be under those slabs can wear away, okay, or it can become compromised. The other thing is some old slabs, they didn't put in moisture vapor retarders in the 50s, right? So it wasn't quite as standard as it is now, right? So if you have something like that going on, that's when you can start looking at moisture mitigation. Again, not for liquid water, not for burst pipes, not for something that can be fixed without moisture mitigation, but for when there's, an issue with the concrete or there's a compromised moisture vapor retarder, right? That's when you can start looking into moisture mitigation. And with that, it's really important as you're choosing moisture mitigations to make sure that you understand what exactly you're purchasing or what exactly you're using. This goes back to what we started the entire presentation off with, which is know your system. right? And that means that you need to know, are you using a moisture vapor barrier or a moisture vapor retarder, okay? And that basically determines the the barrier versus the retarder it determines the permeability or the perms, which is basically the amount of moisture that the barrier allows through, okay? So you can think of it, a moisture vapor barrier is going to allow less water through. A moisture vapor retarder is still going to prevent a lot of moisture movement, but it's not going to be as much. So again, there's nothing necessarily wrong with using a moisture vapor retarder versus a moisture vapor barrier, but you have to think about what you're using above it, right? And whether or not the moisture vapor retarder is going to reduce moisture levels enough, right? And or is that really the applicable thing to be using in your case? If you have a 98% RH slab and you go in with a 95% moisture vapor retarder, that's going to be above what that product can do. So again, kind of knowing what you're using and knowing the difference between these two is very critical. So like I said, make sure you know what you're using, make sure you know what your system can allow for, okay? Now, there are two different types of moisture mitigation technologies. You've got your traditional epoxy. This is the one we all know, right? It meets the ASTM 3010. It's a two-part epoxy system that you mix on site. You have to use the entire kit. And it's something that, the good news is it is a very tried and true system. It's what we've all used most likely for years, right? But it's something to be aware of that you can develop a chemical sensitivity to epoxies, and you have to make sure that they're properly disposed of, right? Anyone that's ever mixed up a whole bucket of epoxy and tried to leave it sit in the bucket knows that you're not going to have a good time, because as that epoxy starts to react, it can start to smoke. So, once you mix it up, if you don't use all of it, you need to make sure that you find a way to dissipate the amount of heat that chemical reaction is causing, okay? The other option, and I hear that we're in the process of making an ASTM method for this, but there's currently nothing published, is a one-component water-based. So the nice thing with this is there's no mixing required, right? You can put the lid back on the bucket, take that moisture mitigation one-part component to the next job site. You don't have to deal with any of the chemical sensitivities or the proper disposal, because it's just a water-based product, okay? So with that, we do offer two different types of moisture mitigation depending on, what you would like to use or what's your preference. We have the traditional epoxy product, which is our Liquidam. You probably might recognize that it's got a very dark blue color. And then we also have our Liquidam EZ, which is a slightly lighter blue color and is the water-based moisture mitigation. So a little bit more on these. The epoxy is going to be a moisture mitigation system. So again, this isn't a moisture vapor retarder. It is a mitigation system. And it can be applied all the way up to 100% RH. But notice that 100% RH, again, doesn't mean standing water, okay? So when we talk about, going all the way up to 100% RH, there's a difference between 100% RH and legitimate standing water within your concrete. This is a product that allows you to, it'll cure in 4 to 5 hours, which means you can prime and be pouring self-leveler or patch over it all in the same day. And you can pour it on new or existing concrete. So again, if you've got a concrete floor where there's a compromised moisture vapor barrier underneath, right, or something like that that's not environmental, this is definitely a good product for that. We also have our EZ, so as you notice, it looks just slightly different. This is the single component moisture mitigation system. It also goes up to 100% RH, and it meets a moisture mitigation, not a retarder standard, which is less than 0.1 perms. You can use it on green concrete after 48 hours, and you have the same day flooring installation, similar to the actual epoxy. So again, the biggest difference between these two is you've got one that is an epoxy and one that is just a water-based moisture mitigation system. So that kind of takes us down through the environmental or the external moisture system. But now let's talk about what I think is more common, which is the moisture of convenience, okay? Moisture of convenience is moisture that's not consumed in the reaction of the concrete, right? So when concrete is mixed, normally we mix in a little bit more water, because it's easier to work, it's easier to use when it's a little bit looser. But what happens is that extra water that isn't actually consumed or used up in that chemical reaction has to go somewhere, right? So we need to figure out where is that moisture going to go, and is it going to cause issues with our flooring, right? So if you have moisture of convenience, so again, moisture of convenience being just that, extra water that is in the concrete when it's poured, you have two options. You can use a high moisture technology adhesive or moisture mitigation. So let's talk about a high moisture technology adhesive. Currently, there's no official industry-wide and agreed upon definition, but typically a high moisture technology or an HMT adhesive is any adhesive that can withstand 90% RH. But it's really important to notice that these adhesives do not block moisture, okay? So again, you have to think about your entire system, not just the flooring, not just the adhesive, not just the leveler, the entire system. Can it withstand the elevated RH or the elevated moisture, right? So these adhesives, while they can withstand those higher, moisture levels, they don't block it from reaching the flooring, which I think is something that sometimes can be misunderstood. So it's really important to understand this isn't a moisture mitigation system, okay? Additionally, it's meant for declining vapor. So normally when fresh concrete is poured, right, there's going to be elevated vapor initially, and then over time it's going to decline as that moisture of convenience leaves the system. That's exactly what these high moisture technology adhesives are designed for, that declining moisture. And another thing to be aware of is these types of products require a moisture vapor retarder, again, that plastic underneath the concrete that's actually intact, right? So if you're doing something at or below grade, you need to have that moisture vapor retarder intact below the slab, okay? Because again, this on its own, this adhesive, does not act as a moisture vapor barrier or a moisture vapor retarder. So it's also important to think about the fact that moisture isn't the only thing that you're thinking about with these adhesives. Fresh concrete, just due to that high moisture, normally has a very high pH. So if you choose not to mitigate, it means that you're also accepting the pH levels of that concrete, okay? Now, some adhesives are going to be affected by high pH. Others are resistant to issues at higher pHs, but it goes back to making sure that it's suitable for the entire system. So if you have an adhesive that is a high moisture adhesive, it can only go up to, let's say, 12 pH, but your slab is at 13. You need to moisture mitigate because that pH isn't acceptable for that adhesive, right? So it's important to understand we're not just worried about moisture, we're also worried about what type of pH you have. And again, especially with fresh concrete, normally you end up with a very high pH. And as I mentioned before, you also want to make sure that you're not just working with adhesives that are high in relative humidity resistance. You also need to make sure that it is the entire system. So not just the adhesive, but your leveler, your prep, your patch, right? And then I just want to add into that, as you're choosing these products, make sure that the cure times are acceptable for what you're doing, okay? So this includes making sure that you know how long it's going to take after you pour that self-leveler, after you install that patch, that you can start installing your moisture-sensitive flooring. So again, with a typical self-leveler, that's normally next day, but if you're using one of the slower set products, it could be, 2 days later. So again, think about when you can go over these products with those moisture sensitive flooring types. There we go. And I just want to reiterate this one more time. Remember that high moisture technology adhesives are not the same as moisture mitigation systems, okay? Just installing the adhesive is not enough if you have high moisture, right, that is beyond what your flooring can take. They are not equivalent, and if you have a moisture issue, you do need to look into moisture mitigation. So hopefully you guys can kind of see how we flowed all the way through here from low moisture to high moisture, and then different types of moisture. So again, if you've got moisture of convenience, in my opinion, always the best bet, moisture mitigation. This is the only way to block moisture from reaching the flooring. And it's a permanent solution for moisture, right? So it means that if at some point in the future the vapor barrier is compromised, or if you just end up with really high moisture of convenience, no matter what, if you moisture mitigate, you're basically protected from these issues, okay? And I do want to add that a lot of times with manufacturers, right, you can often get a longer warranty or a longer system warranty when you moisture mitigate and use, the self-leveling products and the adhesive, right, from one company. You can get a system warranty that is normally longer than if you just used the adhesive. So really, in the end, moisture mitigation is kind of the easiest and the best way to go. Although, of course, we understand that it's not always feasible, which is why we're talking about some of these other options. Okay, so just a really quick reminder, the two products that we offer for this is Liquidam, which is your traditional epoxy, and then your Liquidam Easy. Okay, so again, that kind of takes you through the flow chart, right, of what to do when it comes to, you've got moisture. Now what are you going to do? These are kind of the options that you have, right? You got to determine your moisture source, and you got to either fix it if it's an environmental issue, or look into what your options are for moisture of convenience with either a high moisture technology adhesive or moisture mitigating. So with that, I always like to talk about real world challenges and issues. One that we did recently over at Tech HB Fuller is the Chicago Midtown Athletics. So this was in the last year, and the challenge was Chicago Midtown Athletic wanted to do a full renovation of their entire building in the last year. And that meant removing tennis courts, adding in boxing studios, Pilates studios, and renovating, I believe, 55 hotel rooms that were part of the actual athletic club. So you guys can imagine weightlifting areas, boxing areas, anywhere that you're doing high intensity workouts. This is going to basically, this is going to be a very challenging installation just because of that. So the first thing that we had to deal with was we had freshly poured concrete. So obviously, as part of the renovation, some extra concrete was poured, and we needed to moisture mitigate. So we were able to use our Liquidam Easy to moisture mitigate in areas where there was that fresh concrete. And then we were able to go in and use our Feather Edge patching product to kind of help prepare the multiple substrates for the final floor. So as you can see here, I mean, we were dealing with original tile installations, we were dealing with fresh concrete, we were dealing with, old adhesive residue that we had to figure out what to do with. So there was a lot going on. The nice thing though was, again, we were able to go in with the Liquidam EZ, which, since this was somewhat occupied space, doesn't cause some of those chemical sensitivities, and we were able to moisture mitigate just in the areas that we needed it that had the freshly poured concrete. Okay, so now the really, really big challenge was they had tennis courts, and they wanted to remove the tennis courts to make space for a personal training space, weight training, cardio, fitness with artificial turf, LVP, recycled floor covering. And the biggest challenge with all of this is that all the surface prep and all of the prep that gets done needs to be able to withstand the constant pressure from cardio machines and the impacts from heavy weights. So I'm sure you guys have seen a lot of times when you're doing weight training, you're dropping things on the ground, right? You're lifting things up, and it's big, heavy weights that are having an impact. So you need to make sure that everything that you're installing is going to be able to withstand those impacts and that constant weight, right, from those cardio machines. So at one point in time during a previous renovation in these tennis courts, someone had installed carpet. So we went to go and remove the carpet adhesive, but it was found that it was impossible. But the challenge was that when you started removing the carpet adhesive, grinding it, it started actually tearing up the substrate itself. So in order to prevent that from getting worse, right, in order to prevent the substrate from kind of slowly getting worse as we ground it away, we instead installed a plywood subfloor over the existing substrate so that we didn't compromise it. We were then able to use a multi-purpose primer and a self-leveler that were used to even the transitions between the substrates, and were able to bond to the plywood and could withstand the heavy impact and pressures from the weight machines. So with that, I hope you guys enjoyed our quick talk on knowing your flooring system, knowing where moisture is coming from, and how to choose your system carefully, and a short little case study of something that we had done in the Chicagoland area. And I just want to end that with making sure, don't be part of the $2.4 billion in moisture-related failures every year. Like I said, I'd rather own 4,700 Ferraris than deal with $2.4 billion of moisture issues. And with that, if you guys have any questions, I think we're going to.
Thank you, Heather. We do have a couple questions from the audience. Let me see if I can. There was, what do you think of performing calc chloride in situ RH testing combined?
I mean, I don't think that there's ever anything wrong with doing both. I love hearing that people are willing to do more moisture testing than just one. The biggest thing with that, though, like I said, is that, because there's no direct correlation, you need to make sure that you know what your products can do or what the systems can do it, in both, right? In the RH and then also in the MVER. Like I said, I mean, I think any moisture testing is better than no moisture testing. So like I said, if that's what's easiest for you, I mean, in the end, again, a moisture test is a moisture test. I have, though, of course, and I think most of us have seen in the last, 5-10 years, right? Most companies have been going more to the RH meters just for the ease of use, right? That it's a shorter test. The challenge, though, I would say with it is that because it is technically a destructive test, because you do have to drill into the concrete, if you have like a hydronic heating system, that's where it gets challenging, and I could definitely see doing an MVER or something like that that's less directly, destructive, right? If you don't want to take the chance of drilling into something underneath.
Thank you. Another question we had are, what are the application differences between the epoxy moisture mitigation and the water-based?
Yeah, so that's a great question. Basically the products meet the same specification. However, since that epoxy specification or the specification for moisture mitigation specifically calls out epoxy, we're not able to say that the Liquidam EZ actually meets the same standard, even though it meets all the test performance capabilities. Because the test specifically says it has to be an epoxy, we can't necessarily say that, when we're specifying for architects that it meets that standard. But what I will say is that, like I said, it meets the same performance characteristics. The biggest difference between the two, other than the chemical sensitivities, is a little bit in the application. So when you have the epoxy product, you guys can imagine epoxy is difficult to bond to. So after you install an epoxy moisture mitigation, you also have to prime on top of it. So you have to go in with our multi-purpose primer to prime to be able to go over that with self-leveler, right? So, you've got to have the epoxy, the primer, and then the self-leveler. With the water-based moisture mitigation system, it's a little bit different. You'll actually do 2 coats of the moisture mitigation system, which is a little bit, for some people, you can almost think of it similar to like a water-based, when you're doing like waterproofing in a shower, right? So you're actually going to do 2 coats of the moisture mitigation system, but that second coat also acts as a primer, right? So it's kind of removing a product or a step in that, where you've got a moisture mitigation level 1, level 2, and then you can go directly over it with your leveler or with your patch. So again, with the epoxy, it's going to be the epoxy primer followed by your surface prep. With the water-based, it's going to be 2 layers of the same product and then your self-leveler or your patch. So a little bit different, but in the end, it's a similar number of steps. And actually, the water-based kind of removes a product from the entire system just because it's 2 layers of the same followed by that self-leveler or patch.
Great, thank you. And one other question we had was, what does your warranty cover?
Yeah, so warranties, it's going to definitely depend on the products, right? So I would recommend, depending on what specifically you're looking at, that you check out our website. So the nice thing with all of our moisture mitigation systems is they do go all the way up to 100% RH, right? So it's not a moisture vapor retarder where if we go in and test and it's at 98%, that's going to be an issue. But normally that's, a system warranty is going to be a little bit different than a, product specific warranty. So what I would recommend is you check out our website, And if you can't find the specific thing you're looking for, like I said, go ahead and shoot me an email and I can send that out to you specifically for what you're looking for.
Thank you, Heather. Another question was, do you cover adhesion failure to the concrete resulting from osmotic displacement?
So I'm going to assume that osmotic pressure, we would consider that the same as the liquid water. So again, we don't want to have liquid water is beyond the capabilities of any moisture mitigation system. So that goes back to that has to be taken care of before the moisture mitigation system is put in. Because if you really want to get into the chemistry, basically that liquid water it moves through the concrete differently than moisture, and the product is designed to keep down moisture, but liquid water is separate. So I hope that kind of answers that question.
Thank you for participating in today's webinar. Feel free to contact me at heather.ruhl, R-U-H-L, @hbfuller.com if you have any questions.